Hello, Professor. Myself, Yash Jain. I'm here to present a weekly status report on Maryland vehicle crash. So, so I'll start with the team. So Harsh Bhavsar is the team lead, who is also the business analyst, followed by Dhaval Vasant, who is the data analyst, and then followed by me, who is the developer of this project. So, starting with the introduction of the project. So, the crash report driver data is a comprehensive and vital resource that provides essential information about the road accidents and the drivers which are involved in the accidents. So, this data set compiled and curated from trusted sources provide a comprehensive profile of motor vehicle accidents, which enables scholars, policymakers, and the public to analyze and appreciate the factors that contribute to road accidents and their consequences to the road safety. So what's the project summary right now? We had implemented predictive analysis and now we are reporting the analysis and sharing the insights with the policymakers and the government, and we are recommending also the best possible solutions which will benefit the civilians. So for the preparation of final project submission has already been started. So what we have done since the last weekly status report? We have integrated the code from our IDE to the Jupyter notebook. We are working on the development phase. We are taking care of the SharePoint along with the timesheets, updating with the minutes of meeting. So the project status right now is on track. So in the development phase two, that is the analytics portion, which means the predictive analysis and everything, we have completed that state successfully, and now we are in the dashboard creation phase, so which is currently in progress. So what's our result in that? We have analyzed the data and we have gathered some insights. Now we will be reporting the problem and providing proper solution for it. So how do we communicate with each other? So we had a meeting in person from 7 p.m. to 9 p.m. on the 11th of October. And what was the agenda of that meeting? We discussed insights and prepared a plot for a documentation that we need to be prepared for the analysis which we had observed. So for the future communications as well, we have scheduled team meetings on every Wednesday from 7 to 9. And we will be having meeting again for discussion on our work progress and what will be the role of each team member in that particular phase. So we are as a team joining calls based on the requirement, meeting based on the re-equipment of the projects and its different phases, and also discuss some difficulties if we face during the work process. So the SharePoint setup, which we have already discussed in the last few meetings as well. So we have created a SharePoint setup and provide access to all the team members, which consists of MRP high-level tasks. It shows how the task has been created as per our planned dates. So I will show the yeah, there you go. So our high level task, which contains the all the high level tasks which we have updated. What's the progress of our project right now? As you can see in the visualization, lastly we successfully completed the predictive modeling. So now we are into the phase of documentation. So we will be preparing the documentation. We will be creating a demo dashboard for that as well. So that's everything for the MRP high level task list. Then will be the action items. So what the action item does, it shows the resolved, closed, and the active item related to its MRP project. So that's the action items. As you can see, we have also integrated the budgeted hours task in this, which we got suggestion from the last meeting. So we have included that as well. Then we have the timesheets record for all the work done and for all the meetings, what's the task of each individual, and for whom the task was designed and who completed the task successfully. All the records have been maintained in the timesheets. Then we have the minutes of meeting, in which what was the agenda of the meeting, who was there in the meeting, and what was the observation of that meeting and result of that meeting. So this is all what we have done in the minutes of meeting section, and all these details have been already added in the PowerPoint itself. As you can see, the action items, the timesheets, the minutes of meeting. So the next section, that is the analytical section, will be explained by my co-member, Dhaval. Vasan.
Thanks, Yash, for the detailed explanation of our introduction and the SharePoint. Now I'm going with technicals, that is data visualization and how predictive modeling is done. So going on to the time series predictive analysis. So we have done the predictive analysis using time series model, where we have done this in Google Colab. So this is the code. We have imported various libraries, packages which are required, like NumPy, Matplotlib for data visualization, pandas for data frame, then models for statistic analysis. So then here we have imported Excel, and then the next step is to create a time series for like indexing with time series data. So here maker which sets the index for crash date, where index is the minimum month and the maximum month, and then the speed limit. So visualizing the speed limit with the plot. So as seen, we could see that the graph shows the data from Jan to July, from Jan 2021 to July 2023, and the speed limits are being between 30.5 to 34, and how the speed limits are being how the speed limits are being increased and decreased based on the data. Then this is we have applied the trained and time series decomposition based on our above model. So decomposition is the seasonal decomposition, which has the additive model, and here is the trend. So like trend goes from 32 to 34 based on the dates from like 2021 to 2023. So the speed has significantly decreased from 2021 to 2023. Then we have applied ARIMA model on the forecasting time series data. So there are three parameters which are for seasonality, trend, and the noise in the data. So this is all the output, uh, and then this is this is the ARIMA model which is being featured on the data. So going on to the next visuals, that is our mm, yeah, which is our bar chart for accident count. So going on to the code for this one, this is our code for bar chart, and here the code is for speed limit. This graph is for speed limit based on the number of accidents. So as you could see, the code carries out several data processing and visualization tasks, aiming to gain insights into the correlation between speed limit and the occurrence of accidents. It meticulously calculates and compiles the data on accident associated with each specific speed limit. As a result, a distinct trend emerges. The highest number of accidents tends to transpire within a speed limit of 30 to 40, closely trailed by 40 to 50 speed limit range. The analysis also sheds the light on um, the critical relationship between speed limits and the road safety. So we could see the most of the accidents are caused between 30 to 40 speed limit. Then moving on to the next chart, that is a confusion matrix. So what is confusion matrix? So confusion matrix shows us the true positive, true negatives of our data, which we have predicted. So the code for this one is, uh, yeah, here it goes. So this is the code for confusion matrix, which is used for like it is used for decision trees, then to for decision tree classifier to make the prediction on test data and then evaluate the model. So what confusion matrix is for, like true, if we go to the data, we could see there are instances where model correctly predicted the positives class as positive. For example, the number of cases where the model correctly predicted is no apparent injury, when it was indeed no apparent injury is 27,176. So the same goes for true negatives, false positives. Then false negatives. These are instances where the model incorrectly predicted the negative class, where it was actually positive. For example, the number of cases where the model predicted as class other than no apparent injury, but it was indeed no apparent injury is not explicitly mentioned. So now moving on to the next chart, that is the scatter plot. The scatter plot represented shows the graphical representation between injury severity and the speed limits. So what scatter plot shows is the relationship between the injury severity and speed limits in this graph. X denotes X denotes the speed limit values, whereas Y denotes the severity of injuries. So the code for this is this one. So upon examining the scatter plot, it becomes evident that there is a notable trend specifically where the speed limit falls within the range of 50 to 60 and the injury severity tends to be notably high. So this observation suggests that a speed limit range in this may be associated with higher likelihood of severe injuries. So moving on to the next part, the next chart will be explained by Mr. Harsh Bhavsar. Thank you.
Thank you, Dhaval, for explaining the previous charts. Now, from moving forward, here is the bar chart, which says the top 10 most common vehicle movements. The code for this is here. Uh, Yeah, here we have used the pandas and matplotlib to plot the graph, uh, and the most common vehicle movements and its frequencies. So this is the data we have acquired, and after plotting it, we gathered the data. We got to know that the vehicle moving at constant speed tend to get into the accidents most commonly, followed by slowing or stopping, then stopped in traffic lane. So in this bar chart, it is illustrated that a significant pattern wherein the majority of reported accidents occur when the vehicle are operating at a constant speed, consistent, unchanged speed. This observed indicates that the incidents frequently happen when the vehicles maintain a steady pace. In addition to the accidents involving vehicles moving at a constant speed, the data also reveals that the second highest number of accidents are associated with the vehicle slowing down or stopping. This suggests that the accidents tend to occur during the moments of deceleration or when the vehicles came at halt. Furthermore, the data set also shows a notable occurrence of accidents involving fully stopped vehicles. This implies that the accidents can also take place when the vehicles are stationary, which is critical finding for understanding the dynamics of incidents on road. So with this graph, we actually know that it is not necessary that the vehicle is in a constant speed or moving. Or even stationary vehicle can also get accidented. Uh, this is the most critical moment we have observed. Followed by that, here is our geopolitical chart. Uh, and here is the code for it. So here we have used the pandas and folium. We have imported the folium for the heat map and displaying the major hotspots for the accidents occurring. Here, while zooming it, we can also see the hotspots, and we can also identify the places where the accidents are tend to get happen. So here we have used the heat map, which usually illustrate the presence of hotspots, which indicate of the areas where a substantial number of accidents have taken place. The hotspots on the map serve as a representation of location where with heightened accident frequencies. Upon analyzing the heat map and its hotspot, it became apparent that the majority of accidents are concentrated in a close proximity area to a town area of Maryland. The data suggests that the town area experiences a notably higher incidence of accidents compared to the region, making it a focal point for traffic safety assessment and political improvements. Moving forward, for the challenges we are currently at the stage are reporting and analyzing. We have implemented predictive analysis and now reporting the analysis and sharing the insights with the policymakers and government and recommending the best possible solution. Here are our top recommendations that to improve the road maintenance, the analyze identify the certain road conditions or surface considered associated with the accidents. Speed limit adjustment are also major factor because we have also seen that vehicle moving at a constant speed also get accidented. Identifying the accident hotspots, which we use with our geopolitical model. Predictive policing, implementing predictive policing strategies and leverage the accident severity and predictions. And also with the public awareness campaign, we can raise the awareness in the public to maintain the rules and regulations, and we can move towards the safer driving behavior. This is our current theoretical cost. Activities to be completed is the documentation and reporting the insights from the current data available. And another thing is recommending the best possible solution or change in policy needed from this predictive analysis. That's all from our side. Thank you.